In this video, we'll look at a comparison between two different statements and kind of talk about why it actually makes sense that they are, I'll spoiler, they're equivalent. So we have the two statements, I'm just going to highlight them up here. Negation of P or Q, and the conditional P implies Q. And it turns out by going through the truth table stuff that we've been going through, they are logically equivalent. So let's just go through that real quick. So in order to build negation of P or Q, I'm going to first build the table for negation of P, and that's just flipping the truth values of P. So we have false, false, true, true. Okay? Now if I take negation of P and or that with Q, making up verbs here, oring, remember that an or outcome is true if one of the pieces is true, false if both pieces are false. So true or false is still considered true. It's not exclusive or, right? False or false, that's the only one that's false. True, true is true. False, true is also true. And remember that P implies Q means, well, let's see. If I go back to the original inputs here, if it's true on both sides, it's definitely true. If it's true on the left and false on the right, that's the broken promise. And false, no matter what you end up with on the right, is always true. So yeah, they are logically equivalent. So what we would write is not P or Q, I'll put in parentheses too, is equivalent to, so that's kind of our equals sign version for logical statements. So those are equivalent to each other. Now let's think about that. In the implication, in the if P then Q, if P is false, you don't care what happens on the right. It's going to be a true statement no matter what. Because if the hypothesis is not met, the outcome is basically irrelevant. So that's where the negation P kind of falls into play. And if the consequent or the result, as I'll call it, is true, that means it doesn't matter what happened on the left, I still end up with a true statement. So if the negation of P is true, or the consequent is true, that means the conditional is true. So that's more or less a spoken way to say that these are equivalent as well. So again, this is where we're going. We're getting practice building truth tables and at the same time building logically equivalent statements. So hopefully this makes sense. More on this later.